Well, good afternoon, everyone, and happy Friday, and welcome to this afternoon's webinar, What's New in Mathcad 4.0? And my name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI, and I'm about to pass everything over to Andrew Leedy, who is a applications engineer with PTC. And Andrew's going to take you through a brief presentation of Mathcad and Mathcad 4.0, show you a quick demo, go over some of the new updates, and we should have all of this done in about 20 minutes today. So I'm going to pass everything over to Andrew so that he can get started. Andrew, it's all yours.
Okay, thank you for that introduction. As you said, my name is Andrew Leedy. I'm with PTC, and I'm here to give that quick introduction, the high-level overview of Mathcad. And can you see my screen there, Rob?
I can. PTC
Okay.
Mathcad Prime.
Yes, all right, let's get started then. So before I jump too much into what our solution is and the capabilities of that, I'd really like to just take a step back, go over some of the challenges that we are hearing from our customers and that you might be seeing today, revolving around what Mathcad is able to handle. And one of those problems is that there's a lack of standardized processes and tools to capture calculations and intellectual property. It's all about the engineering process here. We want to document what we're doing when we design for something. We have calculations, we have intellectual property that we want to protect, that shows how it all works, etc. And there are a lot of ways to do this today. Spreadsheets, computer programs, maybe just pencil and paper, the old school way, manuals, and it's spread out all over the company. Everything's stored in different areas, if it's even stored at all. There's also limited sharing and reuse of calculators and intellectual property. So how many times do you do the same thing over and over again, or some people on the team might be doing duplicate work. You just lose information doing it in some of these more old school ways. And errors can be very difficult to catch. There's a story with this Mars probe that made it all the way into space, and then it crashed because one team was using one set of units and another team was using another set. There wasn't a good amount of communication there, and there wasn't a good process because there was no standardized process involved with all these different calculations and such. And so it's all spread out, disorganized. We get all these different errors. So that's where Mathcad is coming in to handle all this. So it's all about analyzing, solving, documenting, and then eventually sharing off our information. So digital engineer notebook, it's a digital engineer notebook to perform your engineering calculations and manage your design intent here. So it houses all your notes, calculations, your plots, graphs, etc. But it's not going to be computer programming. It's very simple and intuitive to use, because it combines the ease and familiarity of an engineering notebook with a powerful mathematical engine. So it's just like your engineering notebook, but it's gonna be neater, more organized, and it also has that engine to define variables, equation, and eventually, and overall, just be able to keep track of it all. So it's intuitive, easy to use, and it's like a whiteboard interface with natural math notation. So X plus Y equals this. No cells to keep track of, no trying to worry about where all your information is on the paper. If you define a variable, you want an equation to call that variable, you just type it out. It's very intuitive to use. It's going to be very comprehensive, so it combines live math, your text, graphics, and programs in a single readable form. So it has everything we need to do, both our calculations and eventually our documentation at the end. It has the capabilities to manage our units automatically, so it understands how to convert everything. It knows that if you're trying to add inches to feet and you want your answer in feet to the end, it knows how to do all that work. You don't have to make sure that you're using one unit all throughout your paper. It's also self-documenting. So it can be shared off, archived, easy to keep track of. And when you share it off, and with Mathcad 4, you even have the ability to control what is going to be shared off. So if you want certain areas to be hidden off, you have the functionality to be able to handle that. So you can very well protect your intellectual property there. It's what you see is what you get. Document editing. So basically whatever you're typing out, it's just like another authoring tool. If you want your text to be this big, you want it to be this color, you can just display it in a very easy way that you're used to with other editing softwares. It has a rich numeric function library, so you don't have to teach the system how to do a function. It has a lot of the stuff already built in. It has a lot of variables already built into the system as well. So if you're looking for some constants, it will have those as well. You can do various different types of plots, X, Y, polar, contour plots. So complete control how we're going to show off our data. Completely with query parametric, and this is where it can get very fun. I can take variables, parameters, calculations, and analysis from Creo, and I could also send values back to Creo. So you got that two-way type of communication that really allows us to drive our design intent and document that design intent. So I have my 3D model completely linked up with my calculations. They're not in two separate worlds here. It allows us to have a more analysis-driven design. So being able to send those values back and forth between Creo and Mathcad to produce an analysis-driven design. We also have verification and validation. So I can change a value and I could double check in both places if this design will still work, and it's all going to be able to communicate that way. Also with Mathcad 4, we've improved the ability to work with other third-party applications. So we're able to more better bring in things from things such as Microsoft Word and some others. And with all that equation stuff that we were talking about earlier, we've improved a lot of the usability around that, particularly with equation wrapping. So instead of having a longer equation run off the screen or you having to manually wrap it yourself, we've managed how it's able to do that and improve the performance around large worksheets, being able to handle that a lot better. So let's take a look at what this would actually look like in a demonstration. So we can just start off with a document that's already started here. If you haven't seen Mathcad before, you'll notice first that it looks like a simple Word document, something that we've been doing for years and years. I can take things, I can format text, all within the ribbon. As I said, very intuitive to pick up. You just say what type of font you want, how big you want it, if you want there to be colors, if you want there to be added symbols, whatever we're going to be doing here. If you want to control how it's going to be placed on the screen with your alignment, control all of that from the ribbon. Now, it even has a grid layout that we can get rid of if we want to, because we might want it to look like an engineering document. So now into some of the actual capabilities here. The first thing, the most simple thing is we're able to do some calculations. So maybe we have some documentation for the beam properties, and we might want to be calculating our beam deflection. So first thing we might want to do is add in a picture. So it can bring in all kinds of different media that we want to display within our documentation, and I can just place that wherever I would like on the screen. Not difficult to bring that in. Now we could put some math in, or I could put some of my materials that we're going to be putting in. So it's going to work the same way as I would if I was writing it down. I define my variables, and then I can use them in a calculation down the road. So if I'd say, well, from that diagram, we have a B and a D, and I want to display an equation for I. So I would go through, type out how we're going to do this. So maybe 1/12 times B, and I might want to try to put in the height, but it's going to flag me if there's an error here. And as soon as I type in what I is equal to, we're going to see, well, this answer makes no sense. And the reason it makes no sense, and you can see that H is a little bit, it has a different color to it. That's because H was a defined variable that the system is recognizing. So it's automatically going to pick that up, say, well, this is already a defined variable. We might have to go through and change that ourselves. And as we go through, change that D, you're going to see it turns from that gray to the black. And now we have an answer that makes sense. I can add in units to any of this, and it will, otherwise it will assume the defaults for myself. Or as soon as I add units into those variables, it will say, well, the default for M is going to be in meters. If I would go through and change that meters to centimeters, it automatically adjusts my value on the inside of the parentheses there. So don't ever have to worry about making errors with your units. I can also check to see if units are compatible. So as soon as I try to add centimeters to seconds, it's going to flag that with a big red and say, I don't know how to read this answer off. This doesn't make any sense because you can't add those units. So a lot of checking your work as we go through here. Now, we probably have data from elsewhere. We also have the capabilities for import and export. Now, as I said with Mathcad 4, we've improved the amount of things that we can import, but the one simple thing we can do is maybe read in an Excel file. So reuse all the existing data that we've been using in our company before. So here I have that Excel. I can define what rows I want to bring in, or if I want to bring in the entire document, I have control over that. And as you can see, it's just going to simply read that Excel file and only bring in those particular rows, those rows and columns. I could even set this to display in a matrix if I want. So I could say, well, what is data equal to? Well, data is equal to those particular rows and columns that is pulling from that Excel file. So really be able to reuse some of the work we've done before to drive that matrix variable. At any time, I can even change the range of that data. So be able to control specifically where see how and have it in and display the entire file. So once it is defined, we can use these values to drive our equation. So I can say, well, pull from that matrix a certain row or a certain column and define that as my Young's modulus of that selected material. And if I wanted to go through and change this further down the road to test out different materials, it'd be very easy to do, just change which row and column you're going to be pulling that from. So here we have another graphic. I can add some variables in my documentation. So I'm going to be defining everything that is going to be driving this graphic. So put those values in, and it's going to ultimately understand units as it goes through any equations that I want to display this on. So use these different values I'm going to put it in to drive the equations somewhere else. So go through and we have our length, we have our width. Maybe we're going to say what that fixed position or the load position is going to be, and then use that going forward. So it's very easy to find an answer to an existing equation that we want to place in further down the road. I might even want to pull in that Young's modulus that we had defined earlier. We can see we have some pre-built equations out. If I want to find the answer to any of these equations, for instance, we're trying to calculate the deflection at x equals L over 2. Well, I know what L, I know what A, I know what W is now. All I have to say is what x is going to be equal to, and it will define that for me and pull from those different variables. As I said, it's going to be able to understand units. So if I ever change my units around, it's automatically going to adjust that answer for Y. We also have the ability to do symbolic derivation. So I can have a region to expand that shows some background information that's driving a major equation. And this is something I might not want to have in my final sheet. I might only want to display the driving forces or the final answer. I don't really care, maybe for the end user, how we got there. I just want to see the final answer, but this will allow us to go through and do some of that background information within the same spreadsheet. And I could also, maybe this is for proprietary use. I have some proprietary equations or some information about some material properties that I want to keep hidden. If I'm sharing the spreadsheet out, I have the ability to control who's going to be viewing that as well. We can put in some plots. So we have a lot of different 2D plots, charts, and graphs we can do. Basically, however I want to display my information, how we're used to displaying our information, I'm able to do. And I don't have to worry about the equations that's going to be driving these plots. I just can control how I want them to look with the visibility and have visibility on what's being changed. So we can say, just as we would with other editing software, if we're used to using Excel, just go through and modify any of these existing graphs. And these are going to be live plots as well. So if I would place down a marker, it will be able to track where I'm at and be able to understand what values are going to be driven from this particular curve. So and have that live plot be driven by those equations and those variables that we defined earlier. We also have some advanced control here, so I can see how this will react maybe as my load varies. And maybe we want to display this in more of a 3D plot as well. So as with the 2D, we can control exactly the look and feel of this. So I can control where we're going to be placed on the graph, if we're going to be looking at it from a certain orientation, if we're going to be displaying this in a particular set of units. So a lot of control over how we can handle the look and feel of this, because the idea is I want to get off this information to my consumer in the most straightforward manner for them to be able to read. And as we said before, this is all going to be live data. So this isn't just going to be a picture here. So as I go through and change my scaling, or I change the direction we're going to be looking at this graph is going to update for myself. So I can get this information off in the correct manner to whoever is going to be viewing this. I can change the color of this. If we're going to be worrying about the thickness. And with Mathcad 4, we've improved the amount of plots we can use and some extra customization ability that we have with those as well. And we can even zoom in on this too. So if I want to zoom in on a particular subset of my data, we're able to get that. Now, last thing I want to look at here is we have the ability to link up with Career Parametric. So we have the documentation and equations laid out for this clutch here. Now, the key input for this can be taken straight from Career Parametric. I did an analysis. We found a torque from within Creo, and I'm reading that data in. So all I have to do is I select a variable and say, well, let's go to our inputs and outputs, and we're going to assign this as an input. So we're bringing this in from within Creo, and it's going to drive our equation here within Mathcad. We have some of the calculations written out here. We have some variables defined, and eventually we're trying to find the number of plates that I want to use in my design. And this is the output that's going to be transformed back to Career Parametric. So we're going to find that as an output and take it into our CAD software. Now, when I go to Creo, I could do some analysis. And what we're going to be doing is something called a prime analysis. And we could see that exact torque input that we're taking out and the number of discs that it was reading in before. So as I said, we're going to find that prime analysis. We can even find it over in our model tree here since we've already used this before. And I can tie this into a worksheet and bring in that data and have that two-way communication with our Mathcad software. So here we can just define define my values, what is the value we're going to be reading back in, what's the value that we're reading back out. And when I want to try a new value, send it over to Mathcad. Mathcad's going to spit out a value back, and my model can be readjusted here. So we can go through, have a lot of control over how that's all going to be managed. If I go to my annotations, as I said, we want to change this torque value. So now we're reading off a 670 torque. We can look at our different, we can look at an orientation to go in on those number of plates. As we regenerate it, it's communicating with Mathcad. It's going to adjust the number of discs and therefore adjust my model. So that is how we're really able to use our analysis to drive our entire design. Now, just to recap what we saw today, really with Mathcad, our main goal, or one of our goals, is to prevent the loss of IP and improve the knowledge capture. So keep everything organized, storable, and manageable. We also want to optimize critical design and engineering processes. So have our analysis-driven design that's going to be linked up with the calculations. And if we're not using Career Parametric and we're not going to have that direct link, we're still able to manage all of our different calculations in a much better way and have everything update through that entire engineering notebook at least. Overall, just be able to improve product quality. No unit screw ups. It's going to be able to understand what values are going to be driving our design, and we're not going to have any problems there. Overall, this is going to be able to speed up our time to market. The system is going to write out our equations, and it really mitigates the screw ups, having that automatic check and balance in place to be able to check my work as I go. And overall, be able to improve compliance with regulations. So documentation can be stored and shared off to anyone. Particularly useful for internal, external auditors. And as I said, we always have the ability, if we're sharing this off, to hide certain areas of our data if we're using some proprietary information. So that's Mathcad in a nutshell. I think we can we have some time for questions if anyone had any.
Absolutely. Nice job, Andrew. Thank you. So please type in your questions in the dashboard at this time. Actually, one question that came in, Andrew, says that asks, you mentioned Creo, but what other CAD systems does Mathcad interact with or work with?
I don't think it has the direct integration that you saw there with any other CAD, but I believe when you do like an import-export, you can send that off as a certain file type. And I'd have to get back to you on exactly what that is sending off.
Okay.
But let me take that offline just so I know exactly what we can send off there.
Okay. So yeah, so it absolutely integrates with Creo. Yeah, so what you're saying is there is some type, there is a way that Mathcad works with the, I guess with other CAD systems as far as the equations within a parametric model, but it's not integrated the way that Creo is.
Yeah, I'm not sure what kind of file formats you're able to import into other CAD solutions to do this kind of analysis-driven results. but I can at least get the outputs that Mathcad can give. So for whatever particular CAD you're using, you can see if it supports that.
Okay. And I believe that is the only question that we have in the queue at this time. So
Okay.
what I want to do is I'm going to take control again for a. I'm going to take control again. If I can do this without, it always gets tricky when I don't have control. All right. So anyway, I want to thank everyone for being on the call today and for your showing interest in Mathcad. If there's any other questions that we can answer for you, if you need a more customized or specified demo, one-on-one demonstration where we can have an open question and answer session concerning Mathcad 4.0, contact us. Our email is info, info at 3hti.com, or you can call us toll free at 866-624-3HTI. And just let us know how we can help you. So, Andrew, once again, thank you for your time today. And most importantly, I want to thank everybody who was on the call today. Thanks, everyone. This concludes our webinar, and have a great weekend.
Thank you.